Hello everyone, we are from Group 6 and we will be presenting on the Hardy-Weinberg equilibrium. The main concept behind the Hardy-Weinberg equilibrium is simple. In a large random mating population that is not affected by the evolutionary processes of mutation, migration or selection, both the allele frequency and the genotype frequencies are constant from generation to generation. The Hardy-Weinberg equilibrium can be expressed by this equation, and we've actually learned this before, so you can go back and revise. For the Hardy-Weinberg equilibrium to hold true, 5 assumptions must be met, which are: the population is large, there is no gene flow between populations, mutations are negligible, individuals are mating randomly, and there is no natural selection. So let's look at what happens in a population where the assumptions are met. The first generation, second generation, and third generation of sheep will have the same allele and genotypic frequencies.
Mutation is one of the processes that disrupt the equilibrium. If a black sheep in the population mutates and starts growing wings, it will be passed down to the next generation, making it a mixture of normal sheep and sheep with wings.
So what happens in natural selection? In this case, the white sheep are easily seen by the predator, therefore they have lower survival rates as compared to the black sheep. As a result, the white sheep's alleles will be slowly eliminated from the population, thus disrupting the Hardy-Weinberg equilibrium.
Gene flow is the transfer of alleles or genes from one population to another. In this example, we have two different sheep populations. What happens when these two isolated populations mix? The allele frequencies for the new mixed population is changed. Therefore, the equilibrium is disturbed.
Non-random mating is one of the factors that actually affects the equilibrium as well. If individuals in a population are choosy in the selection of their mates, the gene frequency will be significantly altered. Like here, when one black sheep stands out, the mating of the sheep is selective, making the probability of the alleles of the black sheep to be passed on to the next generation higher. This is probably what the next generation will look like. In conclusion, this equilibrium is very useful when it comes to studying population genetics like in pharmacogenomics. Thank you for listening.